Right. Hello, everyone. This is a review for Coulomb's law. This one involves the equation of Coulomb's law, which we have F equals K Q1 Q2 over R squared. You're going to need to know how to do the scientific notation math to do this if you're going to plan to retake this quiz. So make sure you also review the scientific notation as well. So for this, we have different variables, and they all stand for different things. F represents the electrostatic force, or in newtons. That's what basically we're going to calculate. Q1 is the charge of one particle, and we usually measure it in coulombs, or C. Q2 is second charge. R is the distance between them, usually in meters. And K is a Coulomb's constant, which we always have at 9 times 10 to the 9. So we're going to practice doing this equation, and you have a practice assignment too if you plan to retake the quiz. There's a few things to remember. For attraction versus repulsion, you can tell whether the charges between two particles attract or repel based on what their charges are. If your solution for Coulomb's law is positive, that means they're going to repel each other. That means they're either both positive or both negative, so they're going to have the same sign and repel. If they have opposite signs, one is positive, one Q is positive, one Q is negative, the solution will be negative, so it means they'll be attracted to each other. Right? So let's do a practice problem. We have two like charges. One has a charge of 3 times 10 to the negative 6. The other has a charge of 1.5 times 10 to the negative 6. And they are 0.12 meters apart. What is the electrostatic force, and do they attract or repel? All right, so let's do this. First, let's list our variables. We know that K will always be 9 times 10 to the 9. Q1, we said one of the charges, so we said one of them was 3 times 10 to the negative 6. Q2, also another charge, and we said it was 1.5 times 10 to the negative 6. And R, we said the distance was 0.12 meters. Let's go just make sure. So right here, 3 times 10 to the negative 6 is one charge, 1.5 times 10 to the negative 6 another charge. They're 0.12 meters apart, and K is always going to be the same number. So that means our F equals 9 times 10 to the 9 times 3 times 10 to the negative 6 times 1.5 times 10 to the negative 6 all over 0.12. And remember, the equation has a squared on it, so this has to be squared. So the equation is F equals K Q1 Q2 over R squared. So the first thing you want to do is change the square so it doesn't confuse you. So 0.12 squared, if you do that in calculator, is same thing as 0.0144. So now we can do like the whole number and exponent trick. So let's do the whole numbers. We have this, 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 and this. Okay. So we're gonna have 9 times 3 times 1.5 all over 0.0144. If you multiply just the top, you should get 40.5, and then over 0.0144, and that should get you, it's gonna be a pretty big number, 2812.5, or 2812.5. All right, now let's do the exponents. You can see the denominators have exponents, so that makes it a little bit easier. So we have 10 to the 9. Make that easy. And 10 to the negative 6, and another 10 to the negative 6, just making sure. Yeah. So we're just going to add all of these. So 10 to the 9 plus negative 6 is same as minus 6 minus 6. That's just 9 minus 6 is 3, minus 6 is negative 3, so 10 to the negative 3. So now we just combine our answers together. This and this. So it was, I'll put it down right here on the side. 28, 12.5 times 10 to the negative 3. You can leave your answer like that, but if you want to make it nicer, input the exponent, not decimal. 10 to the negative 3, you can, since this is like this is a big number, you can reduce it even more. If you multiply this by 10 to the negative 3, or you move the decimal back a few spaces, 3 spaces, you also get 2.8125 times 10 to the 0, which is just 1, so 2.8125 is fine. But you can leave your answer in this format, it'll be fine. But this answer is also right too. All right. Let's do another example. We have another 2 charges. One is 4 times 10 to the negative 5. The other is negative 1.75 times 10 to the negative 6. Oh, wait, I forgot to answer that question. Do they attract or repel? We saw that our answer is positive, so that means they repel. They have the same sign, or they're both charges the same sign, so they're repelling. All right. They are, like I said, 4 times 10 to the negative 5 coulombs, negative 1.75 times 10 to the negative 6 coulombs, and they are 2 times 10 to the negative 3 meters apart. What is their force and do they attract or repel? All right, we can actually answer the last question right away. This is negative, this is positive, so they're opposite signs. They're going to be attracting. All right, now that we know that, let's just answer the question. Like always, let's just do our variables. K is the same thing, 9 times 10 to the 9. Q1, one of our charges was 4 times 10 to the negative 5. Q2 was a negative 1.75 times 10 to the negative 6. And R this time has an exponent, 2 times 10 to the negative 3. So now we can write our equation. Remember, K, Q1, Q2, R squared. So F, our force, equals 9 times 10 to the 9 times 4 times 10 to the negative 5 times negative 1.75 times 10 to the negative 6 and times 2 divided by 2 times 10 to the negative 3. Don't forget the square. I know it's a lot to write, but we have to write it down like that. All right, where's my... So let's do the same thing as last time where we just do the exponents at the bottom. 2 to the power 2 is 4. 2 to the 10 to the power negative 3 to the power 2, that's negative 3 times 2. It's 10 to the negative 6. All right, now that we have that, we can do our, again, base numbers and exponents math right now. So we have 9 times 4 times negative 1.75 divided by 4. I just multiplied across and then divided by the number by 4. So 9 times 4 times negative 1.75 divided by 4. You just use a calculator. You should have got negative 15.75. All right. Now let's do the exponents. I like to color code these so you know like which numbers I'm talking about. All right. So the exponents we have 10 to the 9 times 10 to the negative 5 times 10 to the negative 6 over 10 to the negative 6 again. Okay. So we have 9 minus 5, which is 10 to the 4, minus 6 is 10 to the negative 2, over 10 to the negative 6. Now, whenever we subtract a negative number, this is just the same thing as 10 to the negative 2 plus 6, because negative 2 minus negative 6 is the same thing as negative 2 plus 6. So that answer will be 10 to the 4. Now we do the same thing. We take this number and this number, combine them together. Our final answer is negative 15.75 times 10 to the 4 newtons. So that's our answer. Great. That's it for Coulomb's law for math-based problems, but let's also talk about just like qualitative problems. All right, so let's just talk about, without doing any math, what happens to the force when one of the charges decreases. So let's say Q1 became smaller. Would the force be increase or decrease? It would decrease. Anything that happens here, so on the top part, K, Q1, Q2, if any of them increased, F will also increase. If any of them decreased, F will also decrease. So whatever happens here happens to F. In the bottom, for let's say that distance increases, it's the opposite. So if this number gets bigger, you're going to be dividing by a bigger number. So that means F will be smaller. So what happens to the force when the charges decreases? It decreases. What happens to the force when when the distance increases? It also decreases. So for R, if this got bigger, F gets smaller. If R gets smaller, F gets bigger. So it's the same thing here. So similar thing. It's a little bit of math, but let's just go over it. What happens to the force when one of the charges doubles? So let's say Q1 is twice the amount of charge. F would also be the twice the amount of force. So F will double. So whatever happens in the top happens for F. So if Q2 triples, F will triple. So what happens to the force when the distance doubles? Remember that the distance is squared. So if R is the power 2, it's a little bit more complicated than just if the distance doubles, the F will double too or reduced by half. If R is squared, so let's do this mathematically actually. Let's say everything was 1, R, Q1, Q2, they're all 1. And let's say K was 1 too, just for right now. If F was 1 times 1 times 1 divided by 1 squared, the answer will be 1. But now we're saying that the distance is doubled, so now R equals 2. We have 1 times 1 times 1 divided by, it's supposed to be in parentheses, divided by 2 squared. Do that, we get 1 divided by 4. So that means our force was reduced by a factor of 4. It was divided by 4. So when the distance doubles, the force was divided by 4. The easy way to do this is just plug in what number these stands for. So like doubles means 2, half means 0.5, and see what happens to the F. You'll see that it'll actually be a different number. Right. So that's it for Coulomb's law. The next one will be Kepler's law if you're planning to review that. All right. Thank you.